Welcome to my talk today on Now TV, the challenges we face with linear streaming and how we've managed to scale Now TV to handle the load that we see on these large linear events. So, is anybody unfamiliar with this face? This is Jon Snow. He's a major character from the HBO hit series Game of Thrones. And Game of Thrones is one of the largest shows that we have on Now TV today. It drives massive customer numbers and massive load to Now TV. And much like Jon Snow, when Now TV got knocked down, we got back up again as well. We came back stronger and more resilient than before. And today I'd like to take you through that story, how our service failed at the most critical of times, what we did to fix it, how we responded to those issues to make Now TV the success that it is today. So I'm going to run you through a few introductions about myself, about Now TV and Sky. I'm going to explain what I mean by the linear streaming challenges that I'm talking about. We'll take a look at what happened on the 7th of April 2014. I'll go through the fixes and improvements that we made to our system. And then in contrast, we'll have a look at what happened on the 13th of April 2015. And then I'll also detail some of the things that we're currently looking at, our future work and next steps, and how you can get involved if you'd like to. So firstly, I'm Tom Maule. I'm Solution Architect on Now TV. I've worked at Sky for nearly 5 years now, and I've been on Now TV since the beginning of the project, since it launched, since the project started in early 2012. I started as a developer, and I've now moved on to the architecture side, where I'm overseeing all of the solutions, including the server-side components and all of the client-side apps as well. So for anyone who's unfamiliar with Now TV, it's the standalone, no-contract streaming service available from Sky. Currently in the UK, Sky is traditionally a satellite broadcaster, originally in the UK only, but we've recently acquired Sky Italy and Sky Germany, so we are now expanding and we're becoming the European entertainment company. Now TV is available across a whole wide range of devices, on your mobile phones, on smart TVs and consoles, and we've also got our own smart streaming box, the Now TV box, which is that small black box just underneath the TV there, very, very small little device. So we offer movie and entertainment streaming, and also kids streaming as well, and for the first time in the UK, we offer pay-as-you-go access to Sky Sports, so you can watch your favourite sports games on there as well. Now, we've always had really aggressive ambitions. We launched in the summer of 2012 with just a movies proposition. In March of 2013, we launched sports, so you could start watching your favourite sports games. By July 2013, we'd launched our Now TV streaming box, the first generation of our box. And then in October of that same year, we then launched our entertainment proposition. So those ambitions have led to extraordinary growth. Between April 2013 and April 2014, our customer base tripled. So as you can imagine, this has quite a challenge in terms of making sure we can scale the platform to handle all of these customers, at the same time as making sure that we continue to develop the product roadmap and better the product. Now TV is quite unique among some of our competitors in the UK. If you compare us to the likes of BBC iPlayer and Netflix and Amazon Instant Video, nobody else has the same combination of streaming features that we do. Some people offer VOD streaming, some people offer linear streaming, some people enforce concurrency, but nobody does all of that as well as enforcing DRM across the board as well. So we've got a really unique challenge to tackle that we don't think anybody else has had to tackle. So to try and help put some of this in perspective, this is a quite simplistic diagram of the Now TV architecture. I appreciate that some of you in the back might struggle to see this. Basically, we can easily break it down into two halves. On the right-hand side is the stream transcoding and upload stack. This is where content comes into Sky. We transcode it, we encrypt it, we push it up onto the CDN so that it can be consumed by our customers. And then on the left-hand side is our Now TV platform. So this is where all of the user interactions and all of the content discovery actions occur. So a device will connect to the Now TV platform in order to discover content, in order to authenticate users, to check entitlements, to initiate playout. So on the platform side, on that left-hand side, we're fronted by CDN. We use Akamai as our CDN that performs a lot of cache offload for us. Behind that, we use load balancers to distribute the load across our horizontally scalable applications, of which there are two core applications. One is called content and one is called services. The content application is responsible for serving all of the content metadata and imagery and anything that you might need in order to discover content in the first place. That's backed by a Mongo database, And the services application is the application that is responsible for all of the user interactions, all of the authentication, entitlement checking, purchasing, initiating playout. So all of the content side of things can be quite heavily cached. It's non-user specific. We get a very high cache offload by Akamai, whereas the services side of things is very user specific. It's all authenticated requests, so typically we don't cache anything from that side of the stack. Now, when a device first starts streaming and a user first turns on their box, there's quite a bit of communication between the box and the left-hand side and the platform, where the box is authenticating and pulling down metadata and images and everything else it needs. But once the user's actually started streaming, the video chunks themselves are pulled from a CDN on the right-hand side of the diagram. So once a video is actually playing, the load on the platform is very low. The only thing we get from the device back to the platform during a playout are these occasional heartbeat messages, which I'll go into a little bit more detail later on. So just to make sure that we're all talking the same language here, video on demand, or VOD, isn't anything new. There are lots of big players in the market, YouTube, Netflix, everyone's doing it. But the point of this slide is to point out that typically VOD load is very, very predictable. So this is a graph showing VOD playout initiations over a typical working week on Now TV. You can see from day in, day out, it's the same shape of the graph. And that's very much driven by time of day. So the load during the night, as you imagine, is very low. Everybody's asleep. In the morning, it steps up a little bit. There's a small ramp up in the morning, but then it's really in the afternoon and evening when kids start coming home from school and people come home from work, where the load really ramps up, and it peaks at about 9 or 10 p.m. at night, and then it falls away quite quickly. And then that whole process starts all over again the next day. And even if we look at the load at weekends, so the two on the right-hand side, that's a Saturday and a Sunday, although sort of slightly fatter, slightly larger during the day because there's more people at home, it's still a relatively reliable and regular pattern. So if this sort of load is predictable, then it's great for being able to accurately forecast your load. It's great for being able to perform things like predictive auto-scaling and also to base your alerting on it. If you know exactly how much traffic to expect, you can easily alert when something's going wrong. On the flip side, linear streaming is quite different. Now, unlike most other OTT providers in the UK, Now TV offers linear streaming of TV channels. So while they're being broadcast over satellite or over normal aerial, they're also being streamed through the internet on Now TV. Now, this kind of load is typically not predictable because it's driven by the event on those channels rather than time of day. So if we compare the VOD graph to the linear graph, you can see the VOD graph over the same time period is relatively level, whereas the linear graph, that's a sporting football match, is quite spiky. You get a real influx of load just before a football match is about to kick off, and then it tails away quite quickly. So with all of that in mind, let's take a look at what happened. So Game of Thrones, the biggest show to hit the UK, the US, and around the world, it came to Now TV for its first time in the form of a season 4 premiere. This aired at 9 p.m. on the 7th of April 2014. And I'm sorry to say that we were caught a little bit off guard by it. Our platform was handling everything brilliantly until about 8:53. For the next few minutes following that, we started to see some slowdown, we saw some isolated failures, and by about 8:57, the entire thing fell over. We had an entire system failure, became completely unresponsive, no new streams could be started, all existing streams were terminated, and suffice to say, users were not best pleased. There was some pretty negative sentiment that rippled across Twitter pretty quickly. Our Game of Thrones customers, our entertainment customers, movies customers, sports customers, everyone was affected. Credit to a couple of our customers who came up with a couple of very relative tweets. One customer even went as far as creating some commemorative, memorabilia. So you could purchase a T-shirt with the Game of Thrones logo with our error code underneath it that said, "Oops, something went wrong, please come back later." And you could buy one for your baby as well if you wanted to. So our head of technology at the time actually bought one of these T-shirts and wore it on every single Game of Thrones night following this event. Not sure whether that was a good luck charm or just a reminder of where we've come from. Now, it wasn't just Twitter that picked up on the outage. It was also picked up by some very high-profile news organizations. So the likes of BBC, Digital Spy, and CNET all picked up on the fact that we couldn't handle the Game of Thrones load. It didn't help that just one day earlier, HBO Go in the States, which is a similar streaming service directly from HBO studios themselves, had the exact same problem. They started airing Game of Thrones, and they also fell over because of the load. So it appeared that nobody could handle the popularity of this brilliant TV show. So how did we not see this coming? You would think we'd be prepared for this, we'd know that it was coming onto the schedule, how were we not ready? Well, we did load testing, of course we did. We were confident going into it, but we made some assumptions about those load tests which were very, very incorrect, and I'll try and explain that through a couple of diagrams. So this is a load profile for linear initiations of a typical sports game, a typical football match. For those at the back who can't quite see, there are two peaks, one at 2 p.m. and one at 3 p.m. This was a football match that was kicking off at 3 p.m, and at 2 p.m. there was a sort of warm-up show where the football pundits would start talking about the football and things like that. So you had your diehard fans who were starting the stream at 2 o'clock, and that's where that first little peak comes in, and then people were starting to join the stream over the next hour, and then at 3 p.m. you saw another little peak of people joining before it quickly drops off once the match has actually started. Now, if you look at the highest peak there on the right-hand side, that's about 5 or 6 times the load maybe an hour and a half earlier. So it's still a significant load to have to handle, but we were used to it by this stage. We were handling sporting matches all the time. Now, the problem is that Game of Thrones didn't look like that. Game of Thrones looked more like this. Because there's no pre-event build-up to an episode of Game of Thrones, everybody's coming on at exactly the same time. Within the 5 or 10 minutes prior to the show starting, about 80% of our Game of Thrones customers are all trying to come on. So that load that we just saw distributed over an hour or so is suddenly condensed, and you get this massive peak of people all coming on. So our concurrency, concurrency is a way in which we measure how many streams are currently playing across the entire Now TV platform. That leaped by 2.5 times within the space of about 5 minutes. So we saw our audience basically double, 2.5 times, or more than double within 5 minutes. And this event was 50% higher than any previous linear event that we'd seen before. Even the massive football matches, which, as you all know, are pretty huge in the UK, it was even larger than that. So what exactly happened? Well, all of that load stressed our platform, particularly around our database. And of course, any user that saw an error, the first thing they did was just retry, which just compounds the issue and just makes the load even worse. Users were observing the problems in a whole variety of ways. We saw that existing customers couldn't start new streams. Existing streams where people were already playing out were being terminated. We were seeing concurrency errors where we were telling a user they're not allowed to play out because they've already reached their concurrency limit, and I'll go into a bit more detail on that. We were seeing very high read and write queues across Mongo database, and a couple of our APIs, our entitlement API and our view history API was performing incredibly slowly, and also we spent a lot of time updating indexes in Mongo. So we did some analysis around all of the data we'd collected around that event, and basically came up with 6 areas that we needed to go away and address, and I'm going to go into a little bit more detail about each of those today. So the first one is heartbeating. Now, as I mentioned when I showed the architecture diagram, once a player is streaming video, it makes an occasional heartbeat request back to the Now TV platform. It's roughly every 10 minutes, but just tells us that stream is still playing, so that we know that that user is still consuming video. We use those to enforce concurrency, to make sure that nobody is streaming more than they should be. We also enforce entitlement, so that if anybody's entitlement has expired, then we can revoke that access and we can tear the stream down. And we also use it to record bookmark positions. So anybody who's watching video on demand, we can record a position of how far you are through it so that you can continue on another device. Now, previously and during the Game of Thrones outage, if a player were to make a heartbeat request to the platform and they got anything other than an OK response, it immediately terminated the stream. So in the case here, the device was trying to heartbeat to us. We had gone down. And because we were responding with a non-OK response, probably some sort of system error or network issue, the player was immediately terminating that, tearing the stream down, and the player was kicked off from what they were watching. So we were basically failing in favor of Now TV rather than failing in favor of a customer. We were averting any kind of risk of exposing content for longer than we should have been, and we were being overly cautious, making sure that people couldn't view content when we weren't sure whether they were allowed to or not. So obviously, that's not great for a customer, so we turned it on its head. And today we say the opposite. We say unless we can specifically instruct a device to stop streaming, it should keep going for a limited period of time. So in this way, in the same example, if a device attempts to contact Now TV and it's unavailable, unless that response comes back and says stop, then it will continue. So it can even be a system error, it could be a 500, a 503, or some kind of network error, and it will keep going. So we allow them to continue for that limited period until we can determine that we can specifically instruct that device to stop streaming. So if we have the same kind of issue again today, a lot of users will not be kicked off their existing streams. They'll be able to continue watching. So that was heartbeating. The second issue that we looked at was concurrency. Now, I introduced this briefly earlier. This is the concept of being able to record how many streams a user or the entire user base are currently consuming. Every account on Now TV has a limit of 2 streams, and we manage this through the concept of playout slots. So here we've got a simplistic diagram. We've got the Now TV platform backed by MongoDB, and in the MongoDB there's a document representing playouts for a given account. If a user brings a device along on that account and initiates a play request, we allocate a slot. We basically take a record that they're playing out, and we send everything back to the device that it needs to start a stream, and away it goes. If they then bring in a second device on that same account, we can do the same thing, and they can happily go away and continue to stream. However, you probably see where I'm going with this. If there's a third device, we see that there's 2 streams running, and therefore we block that playout and we say, no, you've already reached your maximum limit. Slots are also updated on heartbeats. So every time we get one of those 10-minute heartbeats back from the device, we update the timestamp in the slot in order to keep that slot fresh. And a slot will expire after about 10 minutes or just over 10 minutes. So if we miss a heartbeat, a slot will expire. And also, if a user presses stop on the device themselves, we get an end event to tear down that playout slot. So in this example where we've got two players already playing out, if the first one is stopped, we receive an end event from that player, we tear down the playout slot in the database, and then if that third device were to attempt to play out, we can happily play out. So it's just a way of enforcing that no one's allowed to stream more than they're allowed to. Now, previously, and on the Game of Thrones night, we have an issue whereby if we don't receive that end event, that playout slot will continue to remain for that 10-minute period and will effectively block a user from being able to play out. So if a device was to lose connectivity, were to lose power, or if Now TV couldn't handle the request for whatever reason, then we get ourselves into a bit of a mess. So in this example, let's say the device crashes and we are unable to receive that end event. The first thing a user will do is turn it back on again. They'll press play again, and that play request will hit us, but we'll go, you've already got 2 streams running, and we'll effectively block that player, even though they haven't. We're basically getting into a point where we had an inconsistent state between the playout slots in our database and the actual real-life playouts. So to solve this, we introduced this concept of slot reclaim. And that's basically the concept of being able to store a device ID against a slot so that we can reclaim a slot based on a particular device. So in this case, we've assigned both slots, box 1 and box 2. In the same example, if box 1 were to crash, next time it comes in, we can now see that there's a playout slot that's already allocated to that device. We reclaim it, we assign it a new ID and update the other bits of metadata in there, and then we can happily allow that device to play out. So we should see no more of those concurrency limit reached errors that we were returning previously. Next time, if our platform were to go down again, or in the case of an app crash, users will no longer be prevented from being able to play out again. So that was concurrency. The third item that we looked at was around our products and entitlement storage. Now, previously, every time somebody purchased something on Now TV, we created an entity in the database to recognize that purchase. So if a user purchased one of our entertainment passes, we'd create an entity in the database, entertainment, for, say, June of last year. And whenever it renewed, we'd create another one. We'd say July of next year. And if they bought, say, a sports pass, we'd create a new entity. And every time it renewed, we'd just create a new entity. Maybe they like us so much, they also sign up for movies. And you can quickly see that we are building up a very large number of entities, which basically represents a sort of purchase history of that user. Now, this was built intentionally in the early days as a way of capturing as much data as possible. It was for business intelligence reasons. We wanted to make sure that we had all the information possible in case we needed it in the future. But since then, those requirements have moved off to another system, so we were able to improve this. And what we really wanted when we looked at it was really we just need a current view of your entitlements. We don't care about your historical, we just need your current. So we mapped the concept of a purchase product to an entitlement, and now if you buy a product, you get an entertainment entitlement. When that renews in July, we just update the existing one. If you buy Sports Pass, sure, you get a new entity in the database, but every time one of those renewing products renews, it basically continues to just overwrite the existing one, therefore keeping the number of entities far smaller in the database. So there's obvious gains here. A reduction in entities is far less data, means far faster queries, much cheaper storage. But another reduction we made around database entities was the fourth item we looked into was our view history API. So every single one of our devices on Now TV offers a view similar to this, where we show the user a history of what they've watched. There's a list of the episodes that they've watched, and underneath each one there's a little progress bar that tells them how far they are through that piece of content. So when a user watches a piece of VOD content on Now TV, we create a viewing entity in the database. And every time they heartbeat for a particular piece of VOD content, we store a bookmark in the database. Now, for legacy reasons, these two entities were stored separately, so we had two different collections holding all of this data. And at the point of a Game of Thrones outage, we had no particular capping or archiving of that data whatsoever. So we had nearly 2 years' worth of every single bookmark that any user had ever created. As you can imagine, that's quite a large amount. So if we take a little closer look at that, for that MyTV view, in order to render that one screen, we had to make multiple database queries. We were having to query the viewings database in order to go and get all of the viewings entities for a particular customer. And then for each of those, we were having to go to the bookmarks database to go and get the position in order to be able to render that progress bar along the bottom. So we were making n+1 database queries, and some users had hundreds or even thousands of items, which meant that that API was performing incredibly slowly indeed. Now, you might be looking at those queries and thinking, couldn't that just be 1+1 query? And yeah, you're probably right. We had an inefficiency in our code that we needed to improve. But we went even one step further than that. Because the requirement to keep the viewings and bookmarks separate was no longer apparent, we decided to merge them. We decided to bring them together. So we created a single new entity called view history. And this was a single record of a piece of content that you'd viewed and the position at which you'd viewed it in. Makes sense, right? Now, one of the quirks of the viewings and bookmarks entities that we were using was the _ID field. Now, if anyone's familiar with Mongo, you'll know that if you don't assign an ID when you drop a document into a database, then they'll automatically assign you a document ID, which is what was happening here. But we weren't using those document IDs for anything. They were just there to uniquely identify a record, and we weren't referencing them whatsoever. So the first thing we did is have a look at it and say, what is the primary key? What is the uniqueness about these documents? And it should be a combination of the account ID and a content ID. It should be who watched what. So we created a compound ID in Mongo to store the account ID and content ID as the primary key, and then we store a bookmark position and a timestamp alongside those. But we went even one step further than that. So anyone who's familiar with document-based databases will know that the field names in a document are stored along with every single document. Now, if you use really long and complicated field names, you're using a lot of extra storage that you don't need to be. So we took those field names and we shortened them. While retaining their human readability, we made them shorter, so things like account ID became AID, content ID became CID, and we actually found that doing this, we saved a massive amount of storage space just by reducing the size of those field names. So I urge anyone who's working with Mongo or a similar document-based database to have a look at doing this, because it does make quite a big difference when you're storing millions and millions of records. Now, so we've made these efficiencies in terms of disk space. We then turned our attention to indexing. So thanks to Mongo, Mongo very kindly gives you an index on that _ID field. You can't delete it. You can't get rid of it. It insists on it being there. It says it's there to ensure that documents remain unique and they're uniquely identifiable. Problem is, we weren't using that field for anything. So we had an index there that was being maintained for absolutely no reason whatsoever, had no purpose, had no value to us at all. On top of that, we then had our custom indexes that we added in order to allow searching by account, in order to allow searching by account and time, and also by account and content ID. Similarly, on the bookmark side, again, Mongo gave us an index which was of no use to us, and we had to maintain it. and we then had our one custom index on top of that. So when we were now moving to our new kind of entity, because we had this new compound ID field, all of a sudden that default index that Mongo gave us was suddenly a lot more valuable, because it now allowed us to not only search by account ID, but also by account ID and by content ID at the same time. So the only remaining index that we needed on top of that at the time was one extra one in order to allow searching by timestamp as well. So we'd gone from 2 entities to 1 entity. We'd gone from 6 indexes down to 2 indexes. And we also implemented an archiving scheme. So any documents, any view history records that were older than about 30 days, we archived off into a separate data store, keeping that data as fresh as possible. So one final item that we also wanted to look at around Mongo was around write locks. Mongo was really quirky back in the days. For anyone who's not familiar with Mongo, you drop data into what they call a document. A document is part of a collection is part of a database, and then a database is part of your Mongo instance. Now, you can have multiple documents per collection, multiple collections per database, and even multiple databases per instance. But the problem was at the time that Mongo had a write lock that was global. So it meant that if you were wanting to, say, write something in collection 1, you couldn't even read from something over here in collection 4 until that write had finished. So every single write and read was blocked based on the previous ones. This was obviously not ideal. So we went away and we worked with Mongo on this, and we upgraded to a newer version of Mongo which changed the write lock from instance level down to database level. But even that is still it's better, but it's still not great. You're still locked based on that entire database. So if you're writing something in collection 1, you still can't read from anything in collection 2 until that write is complete, despite there being completely no relation between that data at all. So that was still slowing us down, and at the time, Mongo hadn't got mature enough to be able to help us out any further than that. So we solved this ourselves, basically worked around it by doing this. We split our most heavily used collections out into individual databases. So that database level locking now meant that effectively you're only really locking the collection rather than the entire database. And that meant that we could get far more throughput through the database than we could previously. Now, last year, Mongo released a new version, version 3.0, and that comes with 2 different storage engines, one of which reduces that write lock down to collection level locking, and another one which reduces it down to document level locking, which is really where it should have been from the start. So we're definitely going to look at adopting those in the near future, and hopefully that should improve our throughput even further. So we've been through and we've made all of these improvements over all 6 of those different areas, and we then needed to go away and basically baseline our performance. We wanted to make sure that we could handle the next season of Game of Thrones that was coming up. So we stress tested our platform. We created a blend of traffic that simulated a Game of Thrones load, including that really aggressive ramp up that we saw 1 year previously. And I'm pleased to say that with all of those improvements, we managed to achieve a capacity of more than 4 times the load that we saw just 1 year earlier. So that gave us a lot more confidence going into that next season of Game of Thrones. It was a fantastic milestone and meant that we could feel a lot more confident around our deployment of Mongo. And it's a pretty good thing, really, because in that same year, our customer base tripled yet again. So yes, we made some headroom, but then we had 3 times as many customers. Despite all of that, despite all of that phenomenal growth, the forecasted load was still comfortably within our capacity for Game of Thrones 2015. So we went for it. Game of Thrones Season 5 came back to Now TV at 9 p.m. on the 13th of April 2015, and it was nearly as exciting for us as it was for our customers. I remember sitting around in the room in the office, hearing the Game of Thrones theme tune, and rather than watching the screen, we were watching the graphs and making sure that nothing was falling over. It was a real moment of truth for our platform. So how exactly did we do? Well, I'm really pleased to say that we handled it pretty well. We handled it without a hitch. We had good platform availability throughout. We saw 2.5 times the load that we saw just 1 year earlier, so a really significant load. And twice the normal concurrency of a Monday night, so twice as many people on the platform as we would normally have on a Monday night. Now, to help put the load into perspective, the graph on the screen here is not a Game of Thrones load. This is a regular Monday night linear load profile. You can see a couple of little spikes around the hour where a new show comes on and people tend to join the stream just as a new show is starting. I'm going to have to zoom out of this graph slightly to get the peak in. We saw about 120 times our regular load at peak. Just at 9 p.m., just as the show was starting, 120 times our normal load for that particular time. But this time around, the sentiment on Twitter was far nicer to read, luckily. People were actively congratulating us and acknowledging the fact that we'd come a long way since the previous year. It was really good that they'd stuck with us through it all and we hadn't lost all of them. So, of course, since then, we've also had another season, Game of Thrones Season 6, which is currently airing. There's one more episode to go in this season. And so far, fingers crossed, everything's gone really, really well. This year was slightly different with the rights that we had for a piece of content. We actually had simulcast rights, which means that when the show was aired by HBO Go themselves in the US, we were able to air the show at exactly the same time. Problem is, because of a time difference, that's 2 a.m. on a Monday morning. So we didn't see a lot of people tuning in at 2 a.m. on a Monday morning, but it did mean that as soon as that had played out on a linear channel, we were able to have the VOD asset immediately available. So when people did come home from work on a Monday evening wanting to watch Game of Thrones, they didn't have to wait until exactly 9 o'clock. They could watch it whenever they wanted, and that helped to dissipate the load and help spread out the load. But saying that, despite all of that, we still saw peak concurrency that evening that was double what we saw a year earlier. So, and remember, that was 2.5 times what we saw a year before that. So really, really phenomenal growth. We've been recognized by a couple of different organizations for the work that we've done in this area. Mongo themselves awarded us with their Innovation Award for 2015 that recognized all of the database performance improvements that we made, some of which I've talked about today. And then also, there's an organization called DTG, which is a digital TV group, who also recognized, also awarded an Innovation Award for Now TV as a whole, including the product offering, the Now TV box, and all of our apps and services. So it's really good to get some recognition for all of our hard work there. So what's next for Now TV? Well, our growth is expected to continue along the same trajectory, so we shouldn't get complacent. We've come a long way, but no doubt next year we're going to have 3 times as many customers to have to deal with again. We've put a lot of effort in recently to our active data center configuration. So this means that we could, in theory, lose an entire data center and continue to support the Now TV service. So we're putting a lot more effort into this and really, really shoring up our resiliency where possible. Something else that I'm quite passionate to look into is around cloud-based overflow scaling. So because we do get these really intense peaks of load, it doesn't make sense to pay loads of money to scale our infrastructure to handle this load that we get for just a few minutes once a week for a few weeks of a year. So it would make far more sense to have a smaller scaled system, but then be able to overflow into the cloud when we need to. But the problem with that is it's so unpredictable. There are some events when we know they're coming, like Game of Thrones, which we might be able to scale up in advance. But we need to remember that that load profile is so steep that if we do it, if we have a reaction, try and scale up based on reactive, then we're not going to be able to scale our nodes up quickly enough to catch that load before it takes us down. So there's going to have to be some clever thinking around how we handle that in future. Microservices, hot topic at the moment, I know. Those 2 big applications that I talked about earlier, content and services, are both quite old now, quite large monolithic applications, and we're starting to break those down into smaller and smaller chunks for the numerous benefits, including independent development, independent deployability, and most important, independent scalability as well. There are some aspects which we need to scale really, really heavily, and other aspects which we can scale far more slowly. And finally, subsystem resiliency. So Now TV is a part of Sky, a much larger organization, and we are dependent on various different components and systems around Sky, and sometimes they do go wrong. So we need to make sure that we can continue to deliver a really good service on Now TV, even when those components become unavailable. So this is all about making sure we build circuit breakers into everything we do, making sure we have sensible fallbacks. If we're not able to confirm that you've got the entitlement to watch a piece of content, maybe we'll just let you watch it anyway and we'll sort it out later. That sort of thing, making sure that we can keep the customer happy for as long as possible. So I just wanted to take a brief moment to thank everyone at Now TV. A lot of work has gone in over the last couple of years. The platform development engineers, the quality engineers, our DevOps engineers especially, who worked really hard with Mongo to make some massive improvements. This was a big team photo of the whole of Now TV when we adopted a new color scheme, which is why we're all wearing really bright clothing. And we are, Now TV is a part of Sky. We are growing, as is Sky. Sky is here today. We have a stand down on level 1. And please do come and find us, come and speak to any of my colleagues. We are looking for some really talented people who might find a passion or might find some of this stuff interesting to come and join us in our London office and come and work for us. So please do come and speak to me or to any of them afterwards. For anyone doing the Devoxx Huntley application, the password's on the screen. I don't think I can take questions in the room because of the number of people, but if anybody wants to ask anything one-on-one, come up to me afterwards. Or my details are on the screen if you want to send me a tweet or an email. But it's been a real pleasure talking you through our story today. That went a lot quicker than I was expecting it to. So I hope you enjoy the rest of your Devoxx conference. Thank you very much.